So I accidentally hit stop instead of pause, or actually instead of start again. But that video itself was getting long enough, so I'll just continue where I was here with this, and you can go back and forth between the videos. But so remember, at this point, I have done two parts of my, come on, go back up here. Two parts of my partial fractions. I've gotten that part done, I've gotten that part done, and I was actually able to just put them together, and I could have done that up here because I've got the s plus the 4 over the same denominator. So I could have done them instead of separately. I could have done the s plus 4 all at once. Okay, but this one I do have to do separately because it has a different denominator. So let me do a page 3, and if I go back, whoops. Okay, so this one's 2 over s minus 4, and then the plus 7 and the minus 3. So, oh, that's kind of weird. Okay, I put a page in the middle. That's okay. You don't care. So here I have the 2 over s minus 4, s plus 7, s minus 3. Okay, and so let me go back and make sure I've got that right. 2, yep. Okay. And so I'll need an a over s minus 4, a b over s plus 7, and c over s minus 3. And again, you know, I just put things together as 2. Now here it gets a little more complicated because when I get that common denominator, I actually have a times s minus 4, oops, not s minus 4, s plus 7, s minus 3, plus b times what it doesn't have, so the s minus 4, s minus 3. And then finally the numerator for this part over here in c is going to be c s minus 4 s plus 7. So once again, I could do the formal thing. I can multiply everything out, and so for me it's just way easier to pick values of s. And so notice that if I let s equal 4, well, that will knock out the b and the c terms, so I get 2 equals a times 11 and times 1. And so a is equal to 2 over 11. And then same thing for b. b, if I let s equal negative 7, that knocks out the a term and the c. So I get 2 equals b times negative 7 and negative 4, that's negative 11, and negative 10. So there's a big number, but I can do 2 over 10 is 5. The negatives cancel. I get b equals 1 over 55. And then finally, for part C, if I let s equal 3, then we have 2 equals c times negative 1 times 10. So in that case, c equals negative 1/5. So if we put that all together, that partial fraction, kind of looking back up here for a minute, right, we had the s minus 4, the s plus 7, and the s minus 3. So we have 2 over 11 times s minus 4 plus 1 over 55 times s plus 7 and then minus 1 over 5 times s minus 3. And again, we can put that together with what we had here. So if we come down and look at that, we had a 3/10 with the 7 and a 7/10 with the minus 3, I guess. Is that right? Is that, yeah, minus 4, yep, okay. So we had the 3 over 10 and the s plus 7. So, I'll come up here. So I can add to that plus 3 over 10 times s plus 7. And again, I need to look at this. And that was a wait, what did I have? I had a negative 4 and then a positive 4. What did I write down here? 3. Wrong. Minus 4. And then a plus 4 over 10 s minus 3. Again, double check that. No. See, that's the problem with going back and forth. Sorry. 3 and a positive 7. Okay. So I might have it this time. You just never know. Okay. So get rid of those, and it's a plus 3 over 10 s plus 7 and a plus 7 over 10 s minus 3. Now I can put those together. This, if I put all that and add it together, I get my 2 over 11 s minus 4 plus. Now here I have 1 over 55, 3 over 10. Eesh. Yuck. Now, so if I multiply this one by 2 over 2, I get 2 over 110. Multiply this one by 11. So I believe I get 35. 2 and 33 is 35 over 110. Now, the nice part is that does reduce s plus 7. And then here I have a minus 1/5, so that's 2/10 and 7/10. So I get a plus 5 over 10 s minus 3. Again, these reduce. I can divide both top and bottom of the middle one by 5, and so I get actually a 7 and a 22, 7 over 22, and here of course I just get a 1/2. Okay, now I'll try to put this back on the first page. So with all that partial fraction stuff, what I find is s is actually, x is actually equal to, well, we have 2 over 11 s minus 4, okay, and then plus 7 over 22 s plus 7, and then plus (1 over 2 s minus 3). Now the constants are no problem. We need to do an inverse. Gosh, I'm missing over here. We need to do an inverse Laplace transform. I'm not sure what I just hit that made that scroll. I never know. It does it every once in a while. Okay, now, so the constants are no big deal, and then I see an s minus 4, an s plus 7, an s minus 3. Well, the inverse Laplace transforms, as I look at the table, all of these I can think of as 1 over s minus a. So that's very convenient. And so what I get when I do that inverse Laplace transform is x of t is equal to 2 over 11, and I get e to the 4t from that term, plus 7 over 22 e to the minus 7t, and then plus 1/2 e to the 3t. Now, and I can check my one initial condition very quickly by just looking at x of 0, see if this all worked out okay. That would be 2 over 11 plus 7 over 22 plus 1/2. Well, that is 4 plus 7 plus 11 all over 22, which is 1. And that was indeed our initial condition way back here, x of 0 equals 1. And I could take the derivative of all this stuff, so I have my x prime. I'm going to do of 0 so I don't write the exponential part. Again, when I take the derivative, I bring down to 4, so I will have 8 over 11. Again, I'm just not sure what I do to make that happen. Then minus 7, so I get a minus 49 over 22. And then here I bring down a 3, so plus 3/2. That's a half, 3/2. And again, changing everything to 22, that's 16 minus 49 and plus 33 over 22, and that is indeed 0. So I think I did something right, and there's our solution. So you see it's very heavy on this partial fractions, or at least can be. It often is. And then the inverse Laplace transform can be a very challenging thing. Sometimes it's not. In this case, it wasn't too bad because everything was of this form, s minus a. Alright, so that does it for that example. It took 2 videos, but we got it.